Pressure in a hydraulic system comes from resistance to flow. To further illustrate this principle, consider the flow produced from a hydraulic pump. The pump is producing flow, not pressure. However, if we begin to restrict the flow from the pump, pressure will result. This resistance to flow is load induced from the actuator, and also generated as the fluid is passed through the various conductors and components. All points of resistance, such as long runs of pipe, elbows, and various components, are cumulative in series and contribute to total system pressure. Pascal's law forms the basis for understanding the relationship between force, pressure, and area. The relationship is often expressed with the following symbol. Mathematically, we express this relationship as force is equal to pressure times area. Pressure is equal to force divided by area, and we can calculate area by dividing force by pressure.
Pascal's law is expressed as follows. Pressure applied on a confined fluid at rest is transmitted undiminished in all directions and acts with equal force on equal areas and at right angles to them. In the following illustration, we have a vessel filled with a non-compressible fluid. If 10 pounds of force is applied to a 1 square inch stopper, the result would be 10 pounds of force on every square inch of the container wall. If the bottom of the container was 20 square inches total, the resultant force would be 10 psi times 20 square inches, or 200 pounds of total force, since force equals pressure times area.
You have completed this training section. Load-induced pressure is defined as pressure generated from the load or force on the actuator. The effective area of the cylinder piston is the area available for force generation. In our illustration, a 10,000-pound force gives us a load-induced pressure of 1,000 psi based on our formula. When the cylinder is extended, the required pressure to move the 10,000-pound load is 1,000 psi, less frictional forces. During retraction, the effective area is only 5 square inches. This increases the required pressure to 2,000 psi needed to retract the load. You have completed this training section. Pressure that is not directly used to provide work may be defined as pressure drop or resistive pressure. It is the pressure required to push the fluid through the conductors to the actuator. This energy takes the form of heat. Excessive pressure drop may contribute to excessive heat buildup in the hydraulic system. This resistive pressure is accumulative and must be added to the overall system pressure requirements. Click on Full Sequence to watch the whole animation uninterrupted.